Hello everyone, welcome to part 4. Here's our chance to start connecting probability and the sampling distributions to the ideas of the hypothesis test. So as you move into part 4, the students will be asked to write down what the claim was. And as they write down the claim, again in this case we're using the lens of the Michigan Department of Environmental Quality, that's the group testing the water, and we'll be looking for evidence that the percentage of homes that have a lead level over 15 parts per billion is actually more than 10%. Now, as students write down the null and alternative hypotheses in symbolic form, it's a good idea to go back and refresh their memory from the previous page on what they meant in words. Now, this helps students connect the words to the symbols, and it really helps them interpret what the symbols mean later. Lastly, in number 3 on this slide, as you're looking at the results from Flint, there are some conditions about normality that must be met in order to use the appropriate tests here. We'll be using a z-test for proportions. So does the sample meet the normality conditions? Again, utilize your textbook. If the textbook has a different rule than what we're giving you here, make sure that you modify and use the one that's in the textbook so you don't confuse the students. The typical one that we use is that we should have 10 successes and 10 failures. We definitely met that. And we also wanted to have a random sample. It was as random as we could have been. Granted, with 300 sent out and 252 sent back in, there could be a little bit of possible bias. And this might be a chance for you to talk about the possible bias there and whether there was any opportunity for Mark Edwards and the team from Virginia Tech to really do anything about that. After that, now taking a look at the sample we received from the data Virginia Tech gave, we go back through the same process we did at the beginning. This time, the students are not using the information in their sample, they're using the information obtained in the real life situation. And now, based on the data, do you believe the claim being made about the population? It's a good question. Remember, the claim was 10% of samples, and if you check this one, it's around 16%. It's a good opportunity for discussion. Remember, 10% and 16% aren't that far off. So if it's not that far off, what are we really looking for? Gives an opportunity for students to also say what they believe about that claim. So give students an opportunity to share. It's a good chance for discussion at this point. Next up, ask them to draw a distribution of sample proportions. Now, they may have already found that on their screen, but by drawing it out, they can actually kind of see where is that center and what does the shape look like for the distribution. The sample provided in the page is a sample that goes all the way up to 60%. And the only reason we go up to 60% is to not give students the idea that you can't get that high with a sample this size, or that it would be very rare for that to happen. So by giving them a lot of opportunities, they can come back and say, okay, I can see that the only results I'm getting are between 0 and 0.2, and they can make an adjustment as they do the graph. And then the key piece is showing where our sample lies. Remember, we ended up at about 16% of homes over that 15 parts per billion. We were only supposed to have 10 according to the null hypothesis. Does that sample seem unusual? And we're really tying this back into the student's initial claim as to whether they believed it or not. Good questions to ask as you go through, and hopefully you'll have a good conversation with your students. Well, let's take a look how you might be able to demonstrate this for your students using technology. So we're going to jump back into the free web app and demonstrate the idea. Again, your software package is fine. Commands might be just slightly different, and the displays as well. Well, let's jump over and see what we end up with. So what you saw right there is web apps will sometimes kick you out. It is a free program, so if you are taking too long or holding it, it's a cloud-based system. And again, if you take too long, it will log you out, and you just simply have to re-enter your data. So I'm going to go back and do my 10% with 252. This time I'm not going to put in the labels, but we can see most of the homes should be on the low end, which would mean they don't have high lead, and there should be some over here on the right. For this one, I'm going to go ahead and get up to 1501 very quickly. I'm going to draw samples for 1,000, click 100, draw 5 more, and then click on 1, and I'm right back to the 1501 samples. Again, I'll adjust my axes so that I'm only down between 0 and 20% because nothing happened outside of that. If we're kind of looking and saying, well, wait a minute, where's our value? Our value is at about 16%. So if you wanted to find the probability of a sample distribution, we could put in a sample distribution of 0.1667. Now, if we find everything that's below 0.1667, you'll notice the proportions below is 100% based on what we had here. Now, even if we dropped a decimal point and did 0.166, we still have 100% of all of the samples that we ran came in less than that. So this can really show a student, hey, that's really rare for me to get up that high. It's extremely rare. If you wanted to, you can drop another decimal just to show them what we're really referring to here. Even to get to 0.16, if we were rounding in just a round down approach, we're at almost 100%. So if you take a look at the number of simulations, 1,500 of them out of 1,501 ended up being less than 0.16. So again, to picture obtaining a value of 0.1667, it's going to be pretty rare. Now this, of course, is going to tie into the p-value that's coming up, but for right now, this helps a student to see that it's really rare. It's unlikely that we would observe this just by chance because we've already done a massive number of simulations. Now, if your students wanted to, they could go, and I'll put in the 6, 7 again, they could go up and do, let's say, 10,000 samples and just draw another 10,000 samples on there, and you'll notice all of a sudden I'm at 0.9997, so we did get a couple samples that were right up near that when we did a few more. We also get something that looks a whole lot more normal, which illustrates why we use the normal distribution to predict from these sampling distributions. Great opportunity to tie technology and sampling distributions into this idea of hypothesis testing. Okay, that wraps up this part. I hope you enjoyed it. A few questions on the quiz coming up. Off you go.